Let's begin the next chapter of this engine building saga. 5 years of work went into designing this rocker arm. Over 70 geometry iterations were FEA analyzed to get to this shape. Additional changes were implemented to tailor the shape to CNC machining. Now you can see that the 3D printed part fits properly into cylinder head, and even this 3D printed part can actuate the valve. The rocker arm has a net shape that is typically forged. It also has 3 important features, such as the bore for the pin, the ball socket, and the adjustment screw hole. This is a threaded hole. The actual part will be heat treated using selective carburizing. This will allow the rocker arm to have the right amount of toughness and ductility while having a hard bearing surface at the ball socket and at the pin bore. My initial idea was to cut this out from plate material. When I started to look for a supplier, I could not find 8620 steel in plate form, at least not in a quantity a home shop machinist could afford. Then I laid out 2 parts in a mirrored arrangement, and after looking at it from all the angles, I realized that the D shape just lends itself to the job. I also tried to lay out in a puck in a cylindrical shape, but that yielded 86% chips, while the D shape is only 79% of material removal. I broke up the process into operations. So operations 100 is basically to cut off a section of the bar with a specific length. Operation 200 is to slit the bar in half. Operation 300 is drill 2 holes in the bar, drill and tap the holes so that I can mount it into a fixture that's being held in a vise. In operation 400, the workpiece would be bolted to this fixture so I can machine the top and the sides. This was my initial idea. The fine machine surfaces were necessary to hold the part in a sacrificial fixture with the flat side bolted down. I went ahead and machined a dedicated fixture for this. Next, I had to machine the D-shaped saw-cut part on 3 sides. While machining the part, I realized that this step can be completely omitted. So instead of starting to machine the rocker arms from the top, I will hold the stock in a D-shaped fixture and start to machine it from the bottom side first. I used Creo Parametric to design the 3D models, and the tool paths were also generated in Creo NC. I used 3 steps to remove the material from the stock: roughing, re-roughing, and finishing. Here's the material removal simulation. First, a 1/2 inch ball end mill roughs out the shape, then a 1/4 inch will do some finer roughing, and finally a 1/4 inch ball end mill will do the finishing touches. Here's the actual machining process. Once the machining is finished on one side, then I end up with this shape. As you can see, the two rocker arms are held together by 4 little bridges. I can just hacksaw through these bridges to get 2 identical parts. The center part, where the threaded holes are, that is discarded. Once the parts are separated, I can use the next custom-made fixture to locate the part for machining on a CNC. So there's a 3/8 size shoulder screw that goes in this hole, and it will just clamp on the part. And then on the bottom of the fixture I have an adjustment screw, and with this screw I can take out any slack from the part relative to the fixture so that it will sit properly during the machining process. Next, the CNC performs the roughing, re-roughing and finishing passes on the top side of the rocker arm. So here's the actual machining process. The resulting parts are awesome looking. You can see small traces, so to say, the fingerprints of the machine. Some of them didn't fare well. On this one, the tool pulled out from the tool holder. That is resulted the roughing going deeper than it should. So when the finishing process comes, it's not getting rid of these ridges. But these other 3, they are looking real nice. When the rocker arm is operating, the highest stress is going to be in this corner here. So you can see what I did in the CAD is there's a 1 millimeter radius going around everywhere, and then it goes up to 3 millimeters, goes around this edge here, and then goes back to 1 millimeter. So the CNC made a great job of carving out this 3 millimeter radius here. Now, some of these fine fingerprints are stress concentrators, so I'm planning to tumble these parts in ceramic media. Let's see if one of these parts will fit. Here's a pin, and it goes through like so, and you can see that the part nicely fits into the cylinder head. There's not much motion when the part is operating, and I removed the outside spring, so I only have the inside spring, which is a lighter spring, but nonetheless you can see that the rocker arm is operating the valve. This is the exhaust side. This part is far from finishing. This size here is 3/8. It's supposed to be 10 millimeters. I need to add the threaded hole here, and I also need to add the ball socket. It has to go through heat treatment, and then I need to get the final size for this bore with honing process. But I think for the first try, that is a real nice component. I have no ways of checking the net shape other than 3D scanning it and comparing it with the actual 3D model. I just don't have that capability right now. Let me know your thoughts in the comments down below, and don't forget to subscribe to see what I work on next. See you on the next one. Bye.